What happens when you take a set of 3 instruct and reward models and have them work together to not just create really great prompt outputs, but actually to create generative AI training data? This is a question that Nvidia had, and obviously Nvidia is mostly known for making GPUs and making a lot of really cool tooling for AI. And this is basically the perfect merging of these ideas with what they released today. So what Nvidia released today is Nemotron 4 340B. It's predominantly cool because it's already beating Mistral 8x22B, Llama 3 70B, and a number of other state-of-the-art models, just with its instruct benchmark. And they didn't just open source this to release a really cool LLM, they also did it so you can create datasets that will make your own models even better. And what's really interesting is earlier this week we saw some really similar research come out about this. So I want to talk about why this is really impactful, what platforms Nemotron is actually intended to run on top of, specifically Nemo and a few other Nvidia NIM services, which have been really big since Jensen talked about them earlier this week at Computex. And I want to go over some other research that was kind of touching on this. So welcome to AI Flux, let's get into it. So first, I want to go over kind of what Nvidia meant to create with this. So Nvidia describes this as a large language model or a set of language models that developers can use to generate synthetic data for training large language models, or LLMs, for commercial applications. So what's also cool is this isn't just meant to be kind of an interesting demo. This is actually something they want people to use to continue basically developing things that require you to buy NVIDIA GPUs or rent time on NVIDIA GPUs, which, makes sense. They say here that through a uniquely permissive open model license, so again, NVIDIA has just created their own license that actually is more open than Apache 2, Nemotron 4 340B gives developers a free scalable way to generate synthetic data that can help build powerful LLMs. The Nemotron 340B family includes 3 different models, base, instruct, and reward models that form a pipeline to generate synthetic data used for training and refining LLMs. Now, the way these interact could technically be described as agentic, but this is really more of a pipeline. So maybe eventually we'll see really cool agentic interaction with these now that the whole sense of mixture of agents is actually a real thing, which we're going to talk about this weekend. But yeah, it's really pretty cool. And obviously these are all optimized to work with some NVIDIA tooling, and that tooling is NVIDIA Nemo, which they briefly talked about at Computex. Basically, as they describe it, this is an open source framework for end-to-end model training where you can kind of plug in your own models and basically use a set of models to create better synthetic data that we now know with a fair amount of certainty is basically always going to give you better results than using a bunch of human data, and also better than RLHF, which is pretty interesting. And of course, it's optimized to also use NVIDIA TensorRT, which is pretty cool. And pretty soon you'll be able to actually use this within kind of NVIDIA's AI playground and as an NVIDIA NIM microservice, which is pretty cool. So what I wanted to jump into is something that I saw earlier this week. What I wanted to go over was some research presented on Twitter by Alan AI from the University of Washington for a model called Magpie. And Magpie has nothing to do with NVIDIA. They probably use NVIDIA GPUs to train this, but what they showed ostensibly was that you could actually use other LLMs to generate a bunch of data, train on top of it, and then have a model that is competitive with GPT-4o. And just a few months ago, the idea that anyone would compete with this was seen as just kind of a fever dream, something that might happen but likely probably wouldn't. So I'll link below to their demo page, which also has a link to their paper, but they give a lot of great information here that wasn't just on their Twitter post. So what's interesting is they describe Magpie as a data synthesis pipeline. And this is why I describe the Nemotron family of models and NVIDIA Nemo more as a pipeline than kind of an agentic framework, especially since it's more intended to generate data to train on and not necessarily work together to just do inference. So they describe it again as a synthesis pipeline that generates high quality alignment data, not just data, but basically highly filtered data based conversationally that helps you create LLMs that are much more powerful than the sum of their parts, which is something initially that merging was created to do. And it's actually in some ways similar to merging because you're basically just creating new data that's better filtered, and you're not just taking existing data sets that you know are good and further filtering and kind of carefully selecting parts of them. What's really important to note here is that Magpie actually doesn't rely on any kind of prompt engineering or seed questions. It's just kind of a rough template for these things. It directly constructs instruction data by prompting aligned LLMs with a pre-query template. So that's what this conversational template is, basically. For sampling, instructions, and then it goes kind of to these few steps. So The pipeline is basically two steps. So you first have instruction generation where you craft input queries and then basically run them through. And that leads us to the second step, which is response generation with a little bit of SFT to filter it and then get it to something that you actually want. And what's cool is we can actually see that in Alpaca eval that using Magpie Pro actually gave better results than SFT and RLHF. So basically the form of just using SFT with Magpie Pro even outperformed SFT and DPO, which is pretty cool. And the great thing with this is, in theory, this means that there can be far less human interaction with some of this instead of maybe doing some final alignment tuning. And I think this is pretty cool. So I'm probably going to make a dedicated video on this, but I wanted to call this out because it's wildly similar to this NVIDIA tooling. And although if I was going to do a ton of work at scale, I would probably use Nemo, but it's cool to see some of the roots of this stuff coming from other researchers that weren't necessarily at NVIDIA. You know, initially we didn't think this was going to be the case, and it's really interesting that NVIDIA kind of thought, oh, well, the cat's out of the bag. We have tooling that already lets you do this. Why not jump on top of this and accelerate the heck out of anyone who wants to do this by basically just giving them the tools so that the infrastructure is less of a hiccup when you're doing this. Obviously, NVIDIA right now is doing everything they can do to remove more of a barrier to using their GPUs and basically to say, yeah, our GPUs are more expensive. Yes, they're also faster. And yes, we also have the best tooling so that the infrastructure stuff gets out of the way and you can just make incredible products and incredible advancements in LLMs using anything made by NVIDIA. Also, these are available in Hugging Face. In this video, I want to get it out as soon as possible, so I'm not going to be able to demo it right away. But if you want to see that, please let me know in the comments. And once I get this going in probably like a 4x A100 or maybe a few H100s, I'll show you guys and we'll see at least how the instruct model is. The reward model was maybe not as good, and the base I'm just not going to mess with. But the instruct model is pretty cool, and I might actually try training something this weekend as well. So I'm curious, is anyone who's watching this going to be using this? What do you generally train on? Have you tried looking into some of this new advancement with mixture of agents? Do you hope someone does a lot of agentic work with this? And do you think that maybe Nemotron for 340B is maybe close to the performance of the now still unreleased Llama 3 400B? We're just gonna have to wait and see. So as always, I hope you learned something from this video. If you like this video, please like, subscribe, and share, and we'll see you in the next one.